All right, so welcome back to this video series or course on Python basics. To recap lecture one, well, I don't think I really need to do this recap because you can just go watch the first video. But these are just like the main things that we did last time. So today, what we will be going over is control flows. So in computer science, the control flow is more easily understood as the flow of control, which is essentially just the order in which each statement is executed. Normally in Python, a statement is executed by top to bottom. If something comes before another, if one line comes before another line, the first line is executed, and then the second line is executed, and then the third line is executed, and so on and so on. Pretty simple. But sometimes we will want to manipulate the control flow. And so the two main ways that we will do this are going to be through conditional programming, also known as branching, and looping. So conditional programming appears in, like, I guess the most common way that conditional programming manifests itself is in the if, elif, else statements. Here we go. And so to demonstrate this, let's open code01 conditional. What an if statement is composed of is, the word if and then a conditional. And so in Python, a conditional would be essentially a comparison statement using larger than, less than, equal to, less than or equal to, and larger than or equal to. Oh, and sometimes you've also got not equal to. These are all the symbols for each condition, respectively. And so an example of a conditional, like in full, would be like 1 is larger than 2, which would be false. And so all conditionals are going to like variable 1 is less than variable 2. That would be like an example of a conditional that you might actually use in a statement. And so in this case, what was I saying? Oh, and so each conditional is basically trying to return a true or false output. So if variable 1 were like 2 and variable 2 were 1, rather counterintuitively, this conditional would output false because 2 is not less than 1. But if it were the other way around, it would give you true because 1 is less than 2. True and false are a type of variable called booleans. So you can see this if you go to the console and say, I believe it's true with a capital T, by the way. Was it this? No. Oh, there you go. Well, you can see there that, yeah, class bool. So true is a boolean right there. And true is equivalent to the value 1, while false is equivalent to the value 0. So if I were to say print true, okay, well, it would print me true, but this is more demonstratable in if statements, but like, I guess just take my word for it that 1 is equal to true while 0 is equal to false. So now that you know what a conditional is, you can see that we use these conditionals in our if statements by saying if conditional command or instruction. And so what happens here is that these instructions only ever happen if this conditional is true. If this conditional is false, then it just doesn't do anything. So we see here that we've assigned late to be equal to false, and this thing should only run if late is equal to true. So clearly, this is not going to do anything because late is not equal to true. Now, if I did that, so if late is not equal to true, then print I need to call my school, and ran it again, I can see that I will now need to call my school, unfortunately, because I am, because why would I need to call my school if I'm not late? Okay, so this does not make much logical sense, but you can see that this condition is giving me false, which means this condition is giving me true, which means that it is executing the instructions underneath it. All right. Then we introduce the else statement. What an else statement does is essentially it'll run if the conditional here, the conditional in the introductory if statement returns a false value. Oh, I forgot to show. Here's a way to prove that false is equal to 0 and true is equal to 1. If I put this the other way around, false, it will still give me the same value. So here it is interpreting 1 as equivalent to the true value. All right, so back to this. Late is equal to true. If late is equal to true, print I need to call my school. And you can see here, since this is returning a true, it executes this line or this statement, and then it completely ignores the else. So it does not print no need to call my school, because the way that this works is that it only executes one of these two statements depending on whether this returns a true or a false. And so else is for if the conditional is false, if is whether the if happens if the conditional is true. You can change this so that it's not true, and you'll see that I will not have to call my school anymore. Okay. Here is another example using the elif. And so an elif is essentially a way to extend the if-else format using a separate statement. Elif is just equal to else if mashed together into one word because that is more efficient, as that is the goal of everything in computer science. And what happens is that elif will only run if the conditional preceding it returns false. So here you can see that if I set my income to 900, it's quite low, but it'll work. It will print 0.0, and then it will not do anything else because this first conditional returned true. Now, if I set it to being 20,000, which is larger than 10,000, oh my god, larger than 10,000, but less than 30,000, you will see that it will skip over the first one because it returned false for this if statement, and then it'll execute the second one because this conditional is true. And then it'll skip the rest of them because they are not needed, essentially. It'll just stop where it deems the conditional to be true. And then, you can demonstrate this again with an income of 80,000, quite the increase. And you can see the tax changes to this one because it's false for these two, but it's true for this one. And then because it's true for this one, you don't need to go any farther than that. Okay. This is a way to order the if-else form in a different way. So in the classic form, you'll have the if, and then the instruction for the if, and then the else, and then the instruction for the else, this being separate. But if you wanted to make it more efficient, which of course you do, you have the variable that you're going to be working with defined first, and then um, you have the if, then your conditional, and then what happens if your conditional returns false, which would be defining your variable in a different manner. Yeah, I mean, there's not much more to say than that. It's a different way of saying if statements, essentially. Okay. Now we move on to our looping. The looping in Python. Okay, it doesn't really have a fancy name. It's just called looping. And so the two main ways that we are going to be looping are going to be using the for loop and the while loop. The while loop is the one that uses conditionals. So that is what we are going to be going over first. I don't have any demonstrations right now for the while loop, so we're going to go and create some. So how the while loop works is that it essentially just repeats until the condition returns, until the condition, I guess, is until a condition is satisfied. The condition, whether a condition is satisfied, can change a lot depending on what the condition is. So let's say I had while n is equal to 0. Okay, well, I gotta define n. N is equal to 0. N is equal to n plus 1. And print n. So you can see here that what's going on is I start with my n equaling 0, and then while this condition, which is while n is equal to 0, so while this is true, n is going to be equal to n plus 1. And then I'm going to print n. So after, if I run this, you can see it's just going to print 1, because by the time n is equal to n plus 1, or n is equal to 1, n is no longer going to equal 0. So it's not going to run anymore. An example of this going on for longer would probably be something like n is equal to 6 while n is less than 0. N is equal to n minus 1, print n. So here we've got essentially we wait until n descends from 6 until it is negative, printing each case of n along the way. And you can see that nothing is happening. Because n never starts as being less than 0. Okay, while n is larger than 0 is what I meant, was what I thought I was typing. And here you go, you can see the effect of the while loop here. So while n is positive or non-negative, it descends after each run, and it prints the result of each descension. You can see the effect changes a decent amount if you go by the normal control flow and go from top to bottom. You can see that it won't print 0. It, like, all the values increase by 1 because you are printing n before you changed it. So this is just a tiny example of how impactful control flows can be. So that's a while loop. Now, getting into for loops, which are more common than the while loop, but the while loop is still pretty important too. The most basic form of a for loop would be using a list essentially, or any sort of Python object that carries values together. Um, and so this would look like essentially for a number, for every instance of a value in a set of values, you print that value, is what this function is saying. And you can see here, for every number in this list, it will print that number. It works just the same using strings and lists. So for string in this is a list of strings, print string. It'll do the exact same thing, only with strings. So it'll print, so for every instance of a value in this set of values, it will print that value. You can also make it do anything that is not printing that value. So for number in 1, 2, 3, what's a function? Print there you go. So this is kind of just like a roundabout way of printing attaboy 3 times. A more efficient way of printing something or doing anything a set number of times is using the range function. And so what the range function does is that it will essentially just give you a range of values according to what you want. And so here you can get like a little overview of the range value. If you just said range by itself, you're not going to get a very digestible output. Like you see, it's just range 0, 9. So the easiest way to understand what range does is by using the list function around it, so that it'll put this range of values into a list. So by just saying range number, it'll essentially give you all the values up to that that number of values starting from 0. So you see range 10 is going to give you the range from 0 to 9, which is not 10, but it is 10 numbers in total because, Python starts counting from 0. Range 9 is going to give you that range from 0 to 9, but 9 is excluded, like most of these Python intervals. The second one, the larger number, is exclusive or excluded. And so you can see this within the calling of the range function itself. So list, list range 3, 8 is going to give you 3, 4, 5, 6, 7, which excludes the 8 but includes the 3. You can also include a third number here if you want to, and this third number refers to the step, which is just the distance between each of your values. If you don't include it, Python will assume that you mean a step of 1, which you can see in these 2 examples where each number is separated by a value of 1. But if you wanted to, like let's say I wanted to count only even numbers, list range 0, 10, 2 for the step, you can see that I'm only counting the even numbers up to 10 excluded. So that's essentially what you're doing. You're creating a list or creating a set of values to iterate over for your for loop when you are saying range. Here, you can run it. Both of these give you the same outcome. Although they're written differently, if I showed you the list form of range 5 is the exact same thing as the list 0, 1, 2, 3, 4. Yeah, there you go. And so this is pretty much another example of what I said with the string example, string demonstration. Oh, I already have that open. Enumerate here essentially gives, here, let me run it. Yeah, enumerate here essentially kind of gives each value in this set of values a key or an index. So what's happening here is that while all of the statements that we've had before have only featured one variable, in this definition spot, you can have multiple by putting a comma in between. So if I really wanted to, I could have a third one, although it wouldn't make any sense for me to have a third one because there's no third one to reference. But you can see that Python, by typing it in, does not see that as like an error. And so what this is kind of just referring to would be in enumerate surnames. So it gives each surname or each value in here a number, and then it'll print position surname. It already knows that from this order, it already knows that the position is going to be referring to the number, and then the surname is going to be referring to the value. Because that's what the function enumerate does. It gives the number before the value. So the order that you put these variables in matters a lot when you're defining these statements. Okay, and so this would be an example of a while loop in action, where if you want to find if you want to turn something from base 10 into base 2 or binary, here's a simple bit of code that can do that. So you start out with 39. You're essentially just you define this empty list of remainders. This is where you're going to store all the remainders that you find. You're essentially just doing n mod 2, so finding the remainder after you divide n by 2, and then filling those remainders into this empty list, and then stopping when n is no longer divisible by 2 anymore. So, this notation here is the exact same thing as n is equal to n floor 2. It's just a more efficient way of writing it. So this reverse thing just reverses the order of the list, which is pretty intuitive. And then you print the remainder. You print it. You print the remainders in the correct order, at least, to make sure that you have the base 2 form of 39 correctly outputted. Now, if I change this to 56, you can see it's going to give me a different number because 56 is a different number from 39, and it will have a different base 2 form. Okay, binary 2. This essentially does the same thing, only it uses a function to do its floor and mod expressions or calculations. But it uses the while loop in the same way, essentially. Is there anything else to say? Yeah, that's about how that goes. Let's see. close all these. All right, this is another case of if statements, essentially. Oh, this is mixing for looping and conditional statements, but not conditional statements. Looping and branching. So here we've got items is equal to 0, none, 0, true, 0, and 7. So both true and 7 would be true, while 0, none, 0, and 0 would all be false. Well, not none, but 0, 0, and 0 are all going to be false. So found is equal to false. This is going to be the flag. For item and items, so for every set of for every value inside this set of values, you're going to want to print scanning item. I'm just walking you through this code at the moment, but the most important thing here is the break thing. So what this break thing does is that it'll take the code right out of this for loop. So even though, so if I run this here, you'll see it'll scan item 0, scan item none, scan item 0.0, scan item true, and then it will not scan item 0, and it will not scan item 7 because we have the break statement, which means it'll immediately take itself out of the for loop and not run for the rest of the values in this set of values. And so, so how this works as a flag is you know how things flag, like warning flags at the finish line, like it's a sign that you found the thing that you were looking for. Oh, and this could be a little confusing. If item, what's if item supposed to mean? Usually when you have something by itself, it just means if item is equal to true. So if item by itself is just another way of saying if item is equal to true. You see, it gives me a bunch of underlined stuff under that because it's saying that's redundant. If item is the same way, has the same meaning, but is shorter. And then, okay, this is just a pretty simple if-else statement. If found, or if found is equal to true, which is what we determine right here. At least one item evaluates to true, or else all items evaluate to false. So if I change this to a 0, you can see that it does not find something true until it comes across the 7. Oh, and I forgot to clarify this. Usually when you see numbers be referred to like true and false, it'll be 1 and 0, but occasionally I think other positive numbers will also mean true as well. But yeah, this is another case of all of these are going to be true because although it's not obvious this time because 7 is the last one in the list, you'll see the flag working the exact same. Now, if I turn to all of these into non-true values, you will see that it'll see that the if statement will find this conditional to be false, skip this, and then head straight to the else. All right. This is not really relevant. It's mostly just another showcase of the break statement. And then, okay. Oh, this actually, okay, actually, never mind. That's not important still. This is kind of important though, because it shows that you can use the else statement for loops as well, which is pretty unique to Python, at least. So the special else clause is one of the features we've seen only in the Python language, is the ability to have else clauses after while and for loops. So if you look at the while and for loops, where suddenly can't find that, you can see that essentially if it can't find the okay, so what's happening here is essentially what this block of code is saying is that if it can't find anyone whose age is larger than 18, it'll print driver not found. Even though this else is outside of the if statement, like its indentation is completely outside of it, it still works because it's correlating to the for loop that contains this if statement. So essentially what it'll do is this for loop is gonna keep going through the list until it finds someone who's older than 18, assign that driver to the person, to the set of values. Oh my God, I can't articulate this well, but essentially it'll look at, okay, so let's say Kirk is 21 years old now. So it'll go through these tuples or these parentheses pairings, I guess, until it comes across Kirk, and it'll see person is Kirk and then age is 21, you know, in the same order as it's listed here. And then it'll assign this person here and then this age here to the variable driver. And then it'll break, as in it'll take itself completely out of this for loop. And so since it successfully found someone to assign this driver variable to, it will not print driver not found. As you know, age is larger than 18. But, so here, let me run this. See, it's not printing anything. But if Kirk is still 9, so backtrack the whole 12 years just now, you'll see that it'll print driver not found because it will not find anyone who is older than 18. So essentially, it's kind of just doing the same thing as this. Oh my God. What? Okay. It's not doing the exact same thing, but it has a similar effect, only it's more efficient to do it this way because you'll be checking everything first before you go to the else statement. Okay, and so that's everything for today. Yeah, I mean, that's it. You got loops, and then you've got if statements. Oh, that's not it.